Hello everyone, we are group 12. I'm Mia Kim.
I'm Piotr Dennis.
So we are going to talk about our project. Our topic is analyzing the efficacy of BERT and SVM mixed model in detecting AI generated text. So as the title already shows, we are going to check single method BERT and SVM, then BERT plus SVM mixed model for detecting AI generated essay. We can use this in real life. We can detect AI usage in educational settings. Also, we can identify AI-generated spam or bot content. Lastly, we can verify documents in corporate or government context. So why we choosing this topic? Because with the rapid growing popularity of AI-generated content has become increasingly widespread. So distinguishing between content created by human and AI has become more difficult. So it raised a concern about plagiarism and misinformation. We found that many studies focus on AI detecting using single method, but few studies explore mixed method to detecting AI-generated content. Therefore, our approach is to evaluate single and mixed method and compare those efficacy. So you can see there's a relative work. Those lists are the relative work we checked. We checked some of a mixed method as well, and its accuracy is pretty good. So you can check later. Here is our link. Okay. And the aim of this project is to test the accuracy and efficiency of data mining algorithm in detecting whether an essay was written by human or AI. We will use visualization to illustrate our findings. The key contribution of this project will be to identify the most effective data mining algorithm for the detection of AI-generated content comparing single method to mixed method. We're going to first look up accuracy of BERT and SVM model, then BERT and SVM mixed model, lastly compare single and mixed model. So first we are going to talk about BERT. BERT is a bidirectional encoder representation from transformers. Why we choose this BERT? Because it is a pre-trained language model, so it understands context bidirectionally and capturing both left and right context of words. It also distinguishes subtle differences in text, so it grasps text meaning and sentences flow effectively. Lastly, it recognizes AI patterns like unnatural repetition or probabilistic structures. This shows how we are going to handle BERT. So we will do data cleaning, tokenization with BERT tokenizer, and then we will split our data 70% for training, 10% for validation, and 20% test dataset. We will use pre-trained BERT based uncased, fine-tune BERT with the classification head, then evaluate using accuracy, precision, record, F1 score, and confusion metrics.
So the other of the models that we've been looking at is a support vector machine. So it's a supervised machine learning algorithm used for classification. And it does this by separating data by finding a boundary that best separates different classes. So most of the data points will lie on either side of the decision boundary. And points that lie on the boundary are called support vectors because they support the position of the optimal boundary. Now, why did we choose SVM? One, it's very effective for classification. And then two, it's flexible to different types of data using different kernels. Talking about the way we're going to mix these methods, BERT is very effective in semantic understanding and feature extraction, while SVM is very effective in efficient classification. So the proposed mixed method that we've come up with is to generate the semantic representation features using BERT, and then use those outputs from BERT in an SVM model to classify the data. The dataset we will be using is from Kaggle, and it contains both AI-generated essays and human-written essays for training purposes. This contains more than 28,000 essays, but we had to cut the dataset to 5,000 essays because of processing power and time constraints. The list of performance metrics we'll be using is accuracy, precision, recall, F1 score, and confusion matrix. These are some of the preliminary results using some of the models. So these are the accuracy we found for BERT and the accuracy we found using the SVM model. We expect that the mixed model will achieve better performance and anticipate that it will have improved runtime and cost efficiency compared to single BERT or SVM models, and that it'll offer comparable or better accuracy than single models. Some of the challenges and limitations of this project, so hardware, BERT consumes significant memory, so it'll restrict the model size and batch size you can use, and it also requires long training and testing time. And due to our limited GPU resources, we can't use larger models like BERT large. Data scaling, we had to as we said before, we had to downscale our dataset from 28,000 to 5,000. And then our dataset may also not be sufficient and large enough to fully verify the model's effectiveness. And lastly, model complexity. It's very difficult to understand models like BERT and SVM. But then it's even more difficult to figure out how to properly combine them into a mixed model. So over the next 2 weeks, we'll be exploring and implementing the proposed mixed model approach. We'll run experiments to compare mixed model performance with single BERT and SVM models. We'll evaluate and check the accuracy of BERT and SVM to ensure the validity. And then we'll prepare findings for final comparison and discussion of model effectiveness. That is our presentation. Thank you for listening.
Thank you.